Hello. So we have seen how to start circuit design for microcontrollers. Now what we'll do is we'll try to understand what we can do in this particular microcontroller using MPLAB X IDE. So what I will do is I will open microchip software programming tool, which is MPLAB X IDE, and I will try to tell you how we can assign each of the pins properly. All right. So what we can do is we can open MPLAB X. This is the start page. Now go to file. Let us start a new project. Then let's start microchip embedded application project. Press next. Then it is asking for the device name. So if you remember, you can write down your device name. So once you PIC16F18346. So I'll take it 18346 series. Okay. I'll just put no tools right now. Press next. You just take down your compiler toolchain, which is XC8. That's all. It is asking for project name. So you can write down PIC16F18346 project. Okay. Project training. So I'll keep it as it is. If you want, you can keep it in some other folder or some other place. So I'll just go browse here and go little up, and I'll just put it as a folder name PIC16F 18346 firmware. Okay. So this project folder is created for me now. I will open it. So this is the like project location that is there. It is asking like it is like quite big. So what we'll do is we'll try to make it little bit small, or it doesn't matter. We'll just finish it. Okay. So this project is created now. Now what we can do is we can try to like bring out our board like this, our like a microcontroller like this, and then we'll assign each of the pins their respective functionalities. All right. So for that, what you can do is there is something called as MCC content type wizard. So this content manager we will press next, and this is how it will get initialized. Okay. So once it has done, then we'll just press finish. So this particular MCC will be enabled. Okay, this is what will happen. Like once you set up the project, this MCC will get enabled, and this is how you will be able to get your GUI so that you can assign the pin naming and their proper functionalities. Okay. Okay, this is done. So what we will do now is, first of all, we will select our like package. So our package is PDIP20 package. So we'll take PDIP20 package. You can drag it, left click and drag it. Now our aim is to assign pin configurations to each of them. Okay. So for GPIO, you don't have to do much work. You can directly click, like a left click and put input output like that. Okay. So let me start one by one. First of all, we start from beginning itself. So RF5 is actually my output pin, which is going to drive the LED. So I'll put it as output. So what we will do is, if you drag it up, you will see you have pins, and you have port A, port B, and port C. So port A, pin number 5, that is port A5, is locked with your like a output pin. So you can see my GPIO output pin, it is locked. Okay. Similar to that, we'll talk about like other output pins. So let's say I will put all of them. So we have LED1 as RA2. So RA2 is here. I'll put that as well as output pin. Okay. Then we'll put it as RC5 as output. So RC5 is also output. So you can see there is a change here that is happening in the grid view, right? Then we have RA0. So RA0 is also output pin, and then RA1 is also output pin. Okay. So that's all. All the output pins are done for the LEDs. Okay. So you can see, if you want, you can, what you can do is, if you want, you can, like generate a code right now just by configuring these LEDs and see your code is fine, everything is okay or not. Okay. So for that, before that, like clock control and everything, you see like everything is fine or not. So let me just, like go here. It is asking for easy view. So HF, like high frequency internal oscillator. So I want high frequency internal oscillator only. So that is fine. HF internal clock, if you want, you can reduce it to 16 megahertz or something like that. That's all. This is fine. Now coming back to register initialization, that is nothing to worry about. Coming back to configuration bit. Configuration bit, only thing you can do is we have external clock oscillator mode. So we will just take it as, like as it is. I mean, there is no need to, like change anything. So external clock above 100, above 8 megahertz. So actually it is not needed. Coming back to watchdog timer, actually I'm looking for watchdog timers. Watchdog timer is disabled. So this is also fine, not a problem. Okay. So everything is done. What we'll do is we'll just generate the code. So once it is generated, you will see code is generated. Come back to project. So once we come back to project, now you see in source file you have main file main.c. So once you double click it, you will be able to see that. I'll just remove them so that you can properly see them. Okay, so this main.file is generated and you can see system initialization is there and everything is there. If you see MC generated file, you have system files. In that source code is there. You have clock, you have configuration, you have interrupt pin, pins and system.c. Corresponding to each one of them, you have header files as well. So in header files, you go here, header files, MCC generated. So you can see clock.h, clock.c. Similar to that, configuration.h, configuration.c. Like that it is there. So you can see if you want pin.h. So in pin.h, my RA5, RA3, all these are initialized. So you will be able to see those pins. Okay. So see here we have RA0. So RA0, RA1 will be there then. Then we have RA2 like that. All the like pins are initialized. Now quickly, if you do not want to make mistake, you can just run once and see if it is building. So this is the run button. So it is a compiling button. So once you compile that, see build is successful. So everything is fine. Now let us proceed again. In the resource management, come here. Let us assign other pins. So our aim is to like assign user push button. So user push button is nothing but your input pin. So that is RC3 and RC4. So what I will do is RC3 will be considered as input. Then RC4 will be considered. I will just enable here pin grid view. So you can see RC3 would have become input. Where is RC3? This is port 3, port C, RC3. Okay. So this is my input. So green is actually, like being made. And as you can see, a green is assigned and corresponding to that little bit purple is there, or like orange is there. So this orange color is restricted, like already it is being used as IO, but so it cannot be used as like output. So you can see GPIO input and output. So input is green one, output is green one here. Coming back to RC3 is done. Then let's go back to RC4. So RC4 is here. That is also my input pin. Done. Then let us talk about dip switches. Dip switches RC1 and RC2 is there. So I have RC1 here, that is my input pin, and RC2 here, that is my input pin. Okay. So RC1, RC2 is also assigned as input pins. All right. So this was all about this. Now coming back to like what other pins are remaining. We will talk about SPI. Okay. So SPI, we have SPI slave select, SDO and SDI and SCK, right? So let us do that. So in that case, in SPI we have device resources here. So in device resources, come down and you will be able to see I2C and SPI everything. So here it is SPI. So just add as a host, because we are going to control this. Okay, so I will be adding as a host. And let us say if it automatically assigns some pin, otherwise I will have to move those pins. Okay, so this is done. Now in this host pin, what is going to happen is I am going to assign pin number. So I have slave select as RC6. So RC6 will be selected as slave select. Okay, so this is how we will be doing it. Okay, so now let us start. SPI host plib selector as, let us say, MSPI1. Okay, so MSPI1, you can see they have been selected as first of all SDI1 and SCK1. This is what it is done already. Okay, so SDI and SCK is selected. Now we have to put it as what? We have SDO and SS pin, right? So if you want, you can do that as well. So here we have this thing, SPI host, right? So do we have option to assign RC6 as, I want it to be, yeah, see here, SDO output he wants. So I have connected, like in my circuit, you can see in the previous video that RC7 was connected as SDO. So I will put it as SDO output. Okay, so this one is assigned as SDO output. Then RC6 will be assigned as slave select input. So slave select option is not there anyway. This is single one, so that is not a problem. Okay, or if you want, you can connect it to SPI. So let me just start SDI, SCK, SDI, SDO, right? So this is how it is connected. Slave select option is not there, not a problem. So this is how it is assigned, and if you generate a code, it will be able to generate the code for you. Okay, so that's all. Now now if you wish to, you can connect as ADCs as well. Okay, so what are the ADCs that is available with us? So we have ADC available with us as RC0. Okay, so RC0 I can put it as ADC input. So this is RC0, this can be connected as ADC input. So how to assign an ADC? So for that, what we have to do is we can just come here in the device resources and select your ADC. So select your ADC here and then add it. So ADC is added in the driver, and this is how ADC is put here. Now let us say result alignment. I'll put it result alignment as right side. Let's say positive reference will keep VDD, and then it is asking for input channel number. So input channel number, if you see, RC0 is ANC0. Okay, so I will connect it, select ANC0. Okay, if you go into the data sheet and you see RC0 pin 16, so let me just show it to you in the data sheet. Alright, so as you can see, the data sheet of PIC16F18346 and 346. So this is the part number that we have. So we'll come down to the pin configuration and it will tell us like what is RC0. Okay, so come down. Yeah, here you see we have 14 pin and 16 pin. Our aim is to go into 20 pin, right? So 20 pin allocation table is this. We have all the three packages, PD packages here. Now come back to RC0. So RC0 is here. So that is my pin number 16. Let me just confirm once. So yeah, pin number 20 pin. This is 16. So this is ANC0. So ANC0 channel. That's the reason ANC0 has been selected as RC0. So this is how it is done. Now coming back to, we have RB7. So let me see RB7 what we had put it. Yeah, we had ambient sensor. So that is also an ADC pin. So this also will be put as ADC, right? So for that what we'll do is we'll just connect it as ADC. Now RB7 is connected as ADC, so you can see there is a change here that is coming up, like ANB7 that is connected, ANC0, ANB7. So this is how you will be accessing your channel names, right? Channel ANC0, channel ANB7, like that you will be able to assign. What else is remaining? RB5. So RB5 is nothing but my temperature NTC. So temperature NTC, as you can see, we had the circuit. We had NTC temperature. Let me just show it to you. See here. We have NTC is where? Yeah, we have NTC here, right? Temperature NTC. So in this temperature NTC, you can see NTC is connected here and this is connected at pin number 12, that is RB5. So RB5 will be added as an ADC. So I'll just come down and ADC input. So you can see RB5 is also added here as ANB5. So this is how we have almost assigned all the pins, except few pins are there. We will complete these two tasks also. But let us generate the code and see what is happening. So we have generated the code. Let me cut these. All right. So we have generated the code. Now if you go to pin.h and open it, you will see that all those pins have been assigned for all the functionalities, right? Earlier it was only few pins for IO pins. Now it has been assigned almost all the pins, right? And you will see some other, these things have been added, like ADC has been added, ADC.h, SPI is added. Similar to that, ADC and SPI has been added, right? So I have already, given a program using some other microcontroller how to call these ADCs and SPIs and run your program. Right now we are actually learning to assign the pin configuration, then we will do other jobs, right? Now let us finish up these two pins as well, RF4 and RC6. So I'll just assign RF4. So RF4 is what pin that we have to find out in our circuit, right? So RF4, if we see, my RF4 is, yeah, this is also one more temperature sensor was there. So as you can see, we have RF4 here and that is coming up as temperature sensor of this analog one, right? So there are two temperature sensors that we had used. So one is this one, a small one, and one more was which one? This is EEPROM. Okay, so that is nothing to worry. We have NTC, right? So what we'll do is RF4 also we will configure at my ADC. So come back, RF4, configure that as ADC. Now coming back to last pin, so we are almost finished. So as you can see, we have done the good job here. So if there is no slave select and it is not being used, right? So we can just try once again. Let us see what is happening. Otherwise, what we can do is this pin we can configure it as some output pin and keep it as it is. So slave select is nothing but your output pin. So I'll just keep it as GPIO output. Okay, so this will be used as a GPIO output to configure. So this is how beautifully you have completed your job to configure all the pins for different functionalities. You can see the pin grid view properly, and you can see my MS SPI, then oscillator is there, then we have reset, we have ADCs, we have GPIOs. All these things are very nicely done. And if you wish to, what you can do is you can generate the code. So once you generate the code, so all these things will be done. So you have successfully initialized all the port pins and their functionalities, and I mean basically you have mapped your microcontroller with their required functionalities. Now what you can do is you can come here main and you can start writing your program. That we'll do in later stage, not now. And what we can do is, first of all, we'll just make sure that the like code buildup is fine. So I am just compiling the code and it is building nicely, not a problem at all. So as you can see, we have successfully built the code. So in the next session, what we'll do is we'll start writing the code for each of the GPIOs and like SPI, ADCs and PWMs, all these things, and we'll try to see how we can do. One more thing I wanted to brought in the picture is, as you can see, we could not do the initialization of like my PWMs and like something like this PWM and I2C. So same process will be done just like we completed ADC and like SPI. This also will be done the same way. Even UART will be done the same way. The only thing is, this pin functionality will get removed and some other functionality will be assigned, right? So alright guys, hope you have now a good understanding how to generate the code using MPLAB X and how to assign the pin configuration for different functionalities. Thank you.